efficiency advantage to memorizing the special products for these binomials. There's no necessity to memorize them because you can still create them on your own with what you know about multiplication. So take, for example, a minus b to the third power. While you could take the time to memorize the format, and we will look at an example to see how it works, there really is not a necessity for that because you can just create it by remembering that a minus b to the third power is really just a minus b times a minus b times a minus b. And remembering what you know or thinking about what you know about multiplication, we can just multiply these one at a time. So, or excuse me, I guess in pairs really, since we're multiplying. So let's multiply those two together first. We get a squared minus ab minus ab plus b squared, which simplifies to a squared minus 2ab plus b squared. That comes from just the first two of the binomials. Now we're going to multiply that by our last one to finish off the creation of the special product. We get a cubed. Well, I guess a better way to do it would be to multiply how we have been. So let's say a times a squared minus 2ab plus b squared minus b times a squared minus 2ab plus b squared. We're going to get a cubed minus 2a squared b plus ab squared minus a squared b plus 2ab squared minus b cubed. We know that a cubed has no dancing partner to simplify with. We know minus b cubed has no dancing partner. If we look at the remainder of the expression, ab squared can be combined with 2ab squared, and minus 2a squared b can be combined with negative or minus a squared b. So we combine what can be combined, and we end with the special product that you see in the picture. But again, the purpose of this is not necessarily for memorization. If you want to memorize it, great. If you think that that's something that would help you, absolutely. But there's no necessity to memorize because you can always just recreate it. However, if you want to see the rule in action, it's probably worth looking at an example where we have the rule being used. Let's take the cube of the binomial 2x minus 3. So the rule says that we cube the first term, we multiply by 3 the square of the first term and the second term without its sign. This rule is set up so that you're not worrying about the signs. The signs are taken care of by the creation of the rule. Then we're going to say 3 times the first term times the square of the second term, again without its sign, minus the cube of the last term, or the second term. We can simplify all of this. This first term becomes 8x cubed. The second one's going to have an x squared with a 3, a 4, and a 3, giving us 36x squared. The next one's going to have just a single x with a 3, a 2, and a 3 squared, giving us a total of 54. And then the last term is 27. I could have got there by just multiplying this out as 2x minus 3 times 2x minus 3 times 2x minus 3. But the use of the rule is probably a little more efficient, provided that you're really good at using the rule and really able to remember all of the pieces and all of the sign changes. There's a lot of similarities in those rules. So to burden yourself with having to remember them is one thing, But burdening yourself with having to remember them and then being able to use them is another point entirely. So worst case scenario, you're just multiplying this out as you would with any polynomial multiplication.